So chapter 13 is about chemical kinetics. So the author starts out this chapter, he has some cute little stories. His little story about how his kids and the neighbor kids would catch lizards. They would get a glass of cold water and they'd sneak up close to the lizard and they'd dump this cold water on him. When a lizard gets cold, it slows down. Slow lizards are easier to catch than fast lizards, right? And so they'd catch these lizards, then they'd stick them in a box and watch them warm up and kind of come back to life. And that was kind of fun. So creatures like this, lizards and other cold-blooded creatures, are called ectotherms. Their body temperature matches the environmental temperature. Unlike mammals, we're mammals, and we maintain a relatively constant temperature regardless of the outside temperature. So what happens when the lizard gets cold? It slows down. But why? The blood gets cold. Blood gets a little thicker when it's cold. But the big thing is the chemical reactions slow down. Why are you able to move your arms and legs? Why are you able to run and jump? There are chemical reactions going on in your body that cause your muscles to move and things to happen. So when the lizard's body gets cold, all those chemical reactions slow down because most chemical reactions are temperature dependent and they happen slower at colder temperatures. So the lizard gets very lethargic and slow when it's cold. That's why lizards like to sit in the sun, right, to be warm. So chemical kinetics is studying the factors that affect the rates of chemical reactions. Temperature is one of those things. Generally, high temperature makes the reaction proceed faster. Other things that affect it are concentration of reactants and or products. The pressure in the environment can affect it. There are a lot of different things. A catalyst can speed it up or slow it down. And what's really important about a study of kinetics is that understanding these reactions, we can control the rates. We can cause the reaction to slow down if we want or to speed up. And there are many different situations in which this is helpful. The rate of fuel combustion. How does a rocket lift off? Vertically. Introducing Mr. Literal here. He's a lot of fun. What makes it lift off vertically? Exploding fuel. There's a combustion reaction that causes the rocket to lift off. Well, what happens if that combustion reaction goes too slowly? It doesn't go anywhere. Or maybe it goes up and then falls over, right? Not good. What if the reaction goes too fast? Kaboom! The thing explodes. So we want to control the rate of that combustion reaction. When we understand chemical kinetics and what affects the rate of that reaction, we can do that, and that's a useful thing. Biochemical reactions. Your body is a chemical factory. I don't even know how many. Gazillions. Make up a number. Gazillions of chemical reactions going on in all of our bodies right now. And your body controls the rate of those reactions. It can't use temperature because we maintain a constant temperature. A lot of the reactions in your body are controlled by the use of enzymes. So an enzyme will catalyze a reaction, will cause it to go faster. Then when your body says, okay, we've done enough of that, it takes the catalyst away, takes the enzyme away, and then the reaction stops or slows down. And so that's a very important use of kinetics. And studying kinetics also helps us to understand how these reactions are occurring. You put these two things together and you get this thing out. But how? What bond broke first? What exactly was happening? We can't just get out a microscope and look at it because it's too small. And so that's kind of, I think what's one of the fascinating things about chemistry is we're studying things that are way too small to be seen. So we have to look at other things to figure out how they're happening.